I like use substitution a little bit more when it's bounded because I don't have to go back in at the end and replace all my u's with what x used to be. Okay, and here's how we're going to do this. Okay, so everyone sees this function, correct? Now, rather than multiply x squared plus 1 out 3 times and then distribute an x, we're going to use u substitution. What should the u be in this case? Yeah. So let's have u equal x squared plus 1. But because I also have a dx over here, and my side work, that's what we'll call it, I need a du, and I'm going to inevitably have a dx as well. So du is going to be equal to what in this case? 2x dx. Now, as I'm comparing and contrasting, it's nice, this x squared plus 1 is taken care of right here. That's going to be u, so it's going to be u cubed, right? What else seems to be taken care of, kind of?
U divided by 2.
Yeah, so if I divide this side here by 2, I'm going to get 1/2 du is equal to x dx, right? Just kind of remembering this back from Friday? Yeah? All right. So, guys, what was I able to do with that coefficient on Friday that you guys got all up in arms about? But yeah, I can put it on the outside. So this 1/2. Now, guys, do me a favor. I know we're bounded, but leave them naked for a second. Yeah, as naked as you are in the shower. Now, okay? Maybe you're not. Maybe you guys take a shower swim time. Now, so guys, over here, this x squared plus 1 is going to be replaced with u to the third. This x in dx is super nice because we're taking care of it with this 1/2, and on the inside I'll put du. Now, ladies and gentlemen, when I was bounded up here, this was in terms of what? This is in terms of x. Do you guys see that? This integral is now in terms of u. The question is, how can I change these x values into u values? Not quite. You see this equation that we have right here? You see how u equals x squared plus 1? Exactly. I'm going to plug in these x values over here to create u values. So what I'm going to do is I'm going to take this lower bound 0, I'm going to plug it in here. 0 squared is still 0, plus 1 happens to be 1. So now my lower bound is 1. Okay? So the reason I can do this is because this entire integral appears in terms of x. This entire integral is in terms of u, so I'm changing my x values into u values by using that equation. So what I'm going to do, take 1, plug it in. What's 1 squared? 1 plus 1. So now my upper bound is 2. You guys okay? That's a small difference today, right? So now we're just going to go ahead and integrate all the way back. So I'm going to get 1/2. This is now going to become u to the what power? If I integrate? No, the 4th. Okay. Now my reciprocal out front, I see some of you guys doing this, but just remember, take this number and do the reciprocal. The reciprocal of 4 is 1/4. Now, do I need a plus c? No, because this function is bounded. And in fact, I've already changed my bounds. Because I've already changed my bounds in terms of u, guys, you don't have to go back in and plug in your x's. Okay? That's the whole purpose of changing these numbers. If I didn't change the numbers, I would have to take this, plug in my x's, then plug in my numbers. But if you change your bounds right away to u's, then we can just go ahead and start solving. So here, I'm going to get 1/8. Now, this is going to be 2 to the 4th, okay, minus 1 to the 4th, okay. Everyone okay with how I pulled that 1/8 out front? Yeah? Okay. So 2 to the 4th happens to be what number? 16. 1 to the 4th is 1. 16 minus 1 is 15, so we get a final answer of 15 over 8, and if you wanted to, you could go ahead and check this in your calculator, and you would see it gives you 15 over 8. You don't have to, but it's a good way to understand if you did it right. Especially with U substitution, because if you didn't, your calculator's doing it the other way. They're doing U substitution, they're plugging the x back in, and then they're using those bounds of 0 and 1. Okay? You guys, what is going on over there? Are we done? Okay. And your final answer is just 15 over 8, because remember, if we have an integral that's bounded, we're bound to get a answer with just as a number. Okay, the only time we're going to get something that's not that is if this was like an x or a variable in there. Okay? All right, guys, so here's example 2. Let's look at this function. I'm going from 1 to 5. It's going to be x all over radical 2x minus 1 dx. Now, looking at what I have, you definitely want to use U substitution. What's the inside function in this case? Okay, so let's start there. So U is going to equal 2x minus 1. First place to start is du. So what should du equal in this case? 2 dx. Now, as I look at this, does this 2 dx help me get rid of that x? It does not. So what do I want to do? Yeah, I'm going to take this top equation and I'm going to solve for x. So I'm going to add 1 to both sides. So u plus 1 equals 2x. So I'm going to divide by 2. So therefore you have u plus 1. That entire thing is all over 2 is equal to x. Okay. So, I'm going to do this one step at a time because there's a lot of places we could get lost. Where do you guys want to start? Where do you want to plug in? Okay, so what do we know x is equal to? Okay. So x is equal to u plus 1 over 2. Yep, I'm going to leave it naked for a second. Okay. What else do you guys know? Yeah, so see, this is a radical, it's in the denominator. I don't want it in the denominator anymore, so I'm going to move this whole thing up. So times u to the negative 1/2. What else needs to be taken care of? So I've taken care of x so far with this u plus 1 over 2. I've taken care of that radical right here. So this dx needs to be taken care of, but what is dx equal to? So I have to divide by 2, right? So 1/2 du is equal to dx. You guys okay? Now, we can. The question is, we can bring anything that's a coefficient to the outside. So what do you guys see as a coefficient? You see this 1/2. There's another 1/2 hiding there. Yeah, so u plus 1. So what's 1/2 times 1/2? Okay, so what I can really do is I can really pull out 1 over 4. Okay, notice I've still left this. Okay, now, what would happen if I took this u to the negative 1/2 and distributed it? You would get u to the 1/2. Yep. Du. You guys okay? All right. Last thing we need to worry about is this is everything here is in terms of u. These. No, I didn't. I pulled the coefficient. You can't pull numbers on the outside. I mean, you can't pull variables on the outside. You can pull coefficients. Right,
So u plus 1 that left there.
right. Okay. So I need to turn this 1, this x that's a 1 into a u. So go over here. What's 2 times 1? Guys, this is the easiest part of this today. 2 minus 1. So notice, it doesn't seem to change, but don't be fooled. That is not the same thing. Okay, this is not the same. I took this x value, I plugged it in, I got 1 for my u down here. Okay? Alright. So now I'm going to take this 5, I'm going to plug it in. 2 times 5 is 10 minus 1. So now my upper bound is 9. Okay? So what I'm going to do is I'm going to take this function, I'm going to integrate it, I'm going to leave my 1/4 out front. So now, this u becomes u to the, what power? If I'm integrating? 3 over 2. The reciprocal of 3 over 2 is 2 over 3, plus u to the 1/2. The reciprocal of 1/2 is 2 over 1. And your bounds that you're plugging in are from 1 to 9. Guys, would you please stop? So, all we're going to do is we're going to plug this in one item at a time. So 1 over 4, 2 over 3, 9 to the 3/2, plus 2 over 1, 9 to the 1/2. And I see a lot of people do like a 9 here and a 1 here. Realize you have to plug it into the entire function. So I'm plugging in 9 there. I'm subtracting 2 over 3, 1 to the 3/2, plus 2 over 1, 1 to the 1/2. Okay? And to make this look a little bit nicer, this is just some algebra. So, the square root of 9 is 3. 3 to the 3rd is 27, but I'm also dividing it by 3, so I end back at 9 times 2. So this right here just turns into 18. If you don't trust me, you can check your calculator. 9 to the 1/2 is 3, times 2 is 6, minus, I get 2/3 plus 2. The ones are easy. And then as you go through and you simplify that, you guys will get a final answer. This is 1 over 4 times, should be 64 over 3. And then that simplifies to 16 over 3. That would be the final answer. Okay. So it's not an S equals. This is the area under the curve. So this is the integral. This is the answer to the integral. This isn't a function. This is a value. Okay. All right. So this next one, I'm going to write it down, but I kind of want you guys to try it on your own to see how you do. Okay? At least the setup, anyway. So your integral is from -2 to 6. The function is x squared times x plus 2 to the 1/3 dx. So go ahead and just start and try and figure out what your u's and du's should be, and we'll move on from there. So you guys need to try and figure out what the correct u is and how you should actually set up this integral, if you can see it. Hello. Hang on. Focusing. There you go. Okay.